Can. Excellent. Hello. Can everyone hear me? Somebody type, oh, good, I can see that you can. Now, one of the things I'm slightly nervous about in giving this talk is that normally in these, when I give a talk, I like to see whether or not I've managed to convince any of the audience to that any of the things I'm saying is sensible by looking into the audience and see who's nodding and who's looking skeptical. Obviously, we can't do that today, so if anybody would like to type nods or look skeptical into the chat while I'm talking, so I've got a bit of a sense as to whether or not this is working out for us, that would be super lovely. Thanks, Adam. Good. All right, let's have a go at this and see how it goes. I'm going to try and talk for about 25 to 30 minutes and then have 15 to 20 minutes for questions. So we'll see how that goes. I'm going to talk a bit about the kind of strategy and philosophy of what we're trying to do, and then I'm going to highlight a few particular areas that I think are going to be particularly exciting around the work that we want to do. Yeah, good. All right, let's give this a try. So you've already heard the tagline from Shirley, a little bit long. Now then, that slide is supposed to have green writing on. So where's my green writing gone? Can other people see green writing on this slide? It's supposed to say data and computers and code and people in big green writing. Right, okay. Well, imagine a slide that says data and computers and code and people in green writing on black, so it looks like a classic green screen background. That's sort of the logo that I tend to use. Anyway, all right. So so imagine that. That's start of the Thanks, Ben. It did briefly appear and disappear, says Shirley. So anyway, I'll type it here, data and computers and code and people, and with the ampersand, you see, so it looks like that, deep Beatles t-shirt kind of thing. And that's sort of the area that we're working on. One of the things so prior to starting, I'll come to a bit more about kind of the career about my story, to get here in a moment, but immediately prior to starting at UKRI, I was at the Turing Institute, and one of the things I like to tell about the story for those of us working in digital infrastructure is this wonderful example from Turing's story that I think embodies this idea of both of the two archetypes that we are together when we're working on when we're working on this stuff. It's the balance between the craftsperson and the scholar. And what we can see here are two pieces of Turing's work. We can see the bombe, the BOMBE, which we used to decipher the Enigma machine, on the right, and on the left you can see the theoretical universal Turing machine, the abstract imaginary. And that example of both genuine, real, practical work. I mean, in what could be more utilitarian than working to win the war, and the theoretical thing in the one thing. That mix of the craftsperson and the scholar is key to the philosophy that I think is important for those of us who work to provide the underpinning supporting technology. Sometimes call it the AI plumbing, and thanks to colleagues in Digital Catapult for that phrase, which makes all of this possible. And it's the excitement and energy around that the importance of supporting research and understanding how to balance those two archetypes within ourselves that I think is really important. I'm going to move on to just telling my story a bit, just because I think when people give these talks, It's useful to know where people are. So a long time ago, particle physicist. I don't know if my mouse pointer is visible on this, but top left. A long time ago, particle physicist. Got a little bit irritated that the switch-on date for the LHC was receding at 1 year per year. Importance of infrastructure and research again. And so moved into doing mathematical and computational life sciences, so doing biosimulation. And during that time as a postdoc, I wrote too much code and not enough papers and didn't get the lectureship at the end. And the little explosion symbol is an indication of the time when one of the two times you'll see here when my career sort of blew up. I also think people who give these talks in conferences and go, hey, I've got this cool new job, I'm doing all this important work. It's really important to tell the stories of the ups and the downs. You know, this thing where, oh, somebody gives a talk, and as far as somebody giving a research talk is concerned, it's like the work is perfect, plain sailing with no problems at all. It's never how it is. Anyway, so and I stand by writing too much code and not enough papers, because what we want to do, craftsperson and the scholar, is do things that are actually jolly useful. And so the fact that doing things that are actually jolly useful was maybe not the best way to win at the academic career game is, it's something that I'll come back to. So then I went to MathWorks for a bit. So some of MATLAB is my fault, sorry. And then I went to a company called, now the slide's gone wrong here again, because that's meant to be the extinction symbol with overlaid over as a transparency over the matrix, the big green writing going down on the matrix. It's only things that are green that have gone wrong. The big green background on the matrix. So that was the logo. That's the sort of logo that to represent this period. When I was working for a company called AMEE, which stood for the Avoiding Mass Extinctions Engine. It was a climate modeling company. It was a Shoreditch startup. And the idea was that we would do mathematical models of human environmental impact. If anybody had passed a carbon tax, I'd have been on the beach now instead of giving this talk, because they would have put mathematical modeling in financial services list. Anyway, that went the way of usual Shoreditch startups and died and exploded. So I came back to academia again, and ignore the UKRI logo in the corner, bottom left. That's just the slide logo, because you have to have the logo in the corner of the slide. Back to academia again, and then in 2012 I set up the research software group in UCL, and this was a group that was in UCL IT and supported people across the university building software in their research projects to have a standard of correctness better than the graph looks about right, and for the code to be usable by somebody other than the PhD student who wrote it, which is a reasonable standard that I think like academia should aspire to. And that led to the growth of the RSE movement, working with the SSI. There are now research software engineering groups in research IT organizations right across the research intensive universities. And that was a really fun part. And that's what really pushes for me the success of that. And this is me blowing my own trumpet a bit. I don't recognize that. That's fine. The importance of doing work in service of science that involves that intellectual commitment and being part of the scholar community. And that thing about being both and a part of the support community and a part of the scholarly community is something I think is really important for us all to get right. And I know when we're working in this space, there are tensions around that, and some weird kind of upstairs, downstairs feelings, a bit Downton Abbey in the academy sometimes. And so getting that right, I think, is in terms of the way we think about ourselves, is really important. Then I went to the Turing Institute, UK's National Institute for Data Science and Artificial Intelligence, and did a similar thing there, and then moved to this job at UKRI. So that was the egotistical slide where I talk about how I got here, but I think it's useful in context. And the other Turing story, I just want to drop this in before I move on to some particular examples of novel areas of computational science that I think the infrastructure is going to be critical to. is to emphasize that in addition to the craftsperson and scholar, another critical role of those of us working on the common and underpinning infrastructures for research, for digitally based research, is interdisciplinarity. We are bringing these tools and these capabilities to domains that might otherwise not have used them, and this will it's something I emphasize in the next few slides. This is a picture of the zebrafish. Not many people know that in addition to inventing computer science, Turing also invented large areas of mathematical biology. Just have a holiday, you know. It's like, okay, I know what I'll do. I'll pause being a computer scientist for a while. I'll go off and do something else. So it built a model which he thought explained how the stripes form on a zebra. Turns out it doesn't explain how the stripes form on a zebra, but does explain how the stripes form on a zebra fish. So I use this slide to remind us of that story of that importance. So now what I want to talk about is a few example areas of thanks, Dave. A few example areas of this point about one of the things that's really exciting for me at the moment is that we are bringing the power of digital research, and this is something that comes out very strongly in the Research 4.0 work that JISC have been doing. We're bringing the power of digital research, of using computers and data to do research in many more areas than historically have been the focus of it. You know, this is no longer digital research e-scholarship. It's no longer something that sits in the EPSRC domain and the SCFC particle physics domain. You know, it's right across all of research. So this is a project I'm involved in called Living with Machines, and this is my sort of research hat on, which is doing 19th century history, the history of the Industrial Revolution using digital methods. We have all of the 19th century in a computer, well, in the cloud. All the 19th century books, all the 19th century newspapers, the Ordnance Survey from the 19th century censuses, and we can analyze, do historical research through digital methods. And so for me, one of the key things that I'm excited about in terms of why UKRI and the coming together of the research councils decided, and this is why a big part for me of why I wanted to take this challenge on, because UKRI has decided to create a post, a directorate for digital research infrastructures at the UKRI level, we can make these capabilities, these infrastructures available right across all the research domains, taking arts and humanities and social sciences no less seriously in the importance of digital methods than we do the power of computing and data in the physical sciences. And I think that's tremendous and really important. Another example of some work that I think is going to be particularly exciting in the computer. So this slide is an illustration from the National Digital Twin project, which is led from the Centre for Digital Built Britain in Cambridge, and another project I'm involved with, which is about building the data models to allow us to make computational models of all kinds of things in the built environment interchangeable, so that we can do at scale digital twins. And a digital twin, just to explain, digital twin means we take what we've always done in advanced modeling and simulation, where we have a finite element model of a bridge, or a computational fluid dynamics model of a turbine, or any of those kind of things, and we couple that to the physical equivalent, so that there's a bidirectional coupling through telemetry or other means between the digital copy and the physical copy. And that augments what we've always done in terms of advanced modeling and simulation through a powerful network and through advanced telemetry in the Internet of Things, and brings those worlds together. We've been thinking about the world of supercomputing, advanced modeling and simulation, the world of the Internet of Things is quite separate. But digital twins, excitingly, brings that together and brings what we do in supercomputing into connection with the work we do in advanced networks and Internet of Things and telemetry. And we can. So one of the things we would like is not through this is not just to be able to say to ask a query engine, tell me all the towers in. This is a classic example we always use. Tell me all the towers in the UK that have got the same planning as Grenfell, but connect that to models of the transport network for the travel time of emergency vehicles. Connect that to social data of who's living where and what occupancy levels are, and actually start to make a plan. This is the example we use of how to order the retrofit to fix this with an evidence-based basis. And you recognise this, of course, when we think about what we're doing now in terms of the use of digital methods in planning and modelling for the response around the pandemic. In very sad circumstances, but it is, we are seeing the importance of mathematical modelling of viral progression through the population in determining strategy. And I think that the combination of the work we've been doing for some time now in mathematical life sciences, in the virtual physiological human, and so on, with social data, with digital twins, and enabling us to have that digital view of the world to evaluate policies is going to be one of the key things that emerges from this crisis. But let me pause for a moment, because I don't want to give an overemphasis of the importance within this of the shiny, glamorous end of the mathematics, the shiny, glamorous end of the writing of applications that describe the underlying physics, or the writing of the clever mathematics of machine learning models. When we, when I think about the work that we've done, so here's a story about my experience of data science projects. The first 40% of any data science project is information governance, being allowed to access the data. Not even doing data wrangling yet. We've gone from agreements in principle between the research organization and the people who might have the data set. The work to actually get the data onto the lab's computer so you can start to work with it is, it's a huge important part of the project, and I'll come on to the importance of data stewards and why that's such a critical role within digital research infrastructures towards the end of the talk. The next 40% is the data wrangling, getting the data out of the spreadsheet or some kind of PDF and into a database. And only the last 20% is the glamorous piece that attracts a lot of research council interest. And this is one of the things that my role should help to shift. Is, again, this is coming back to the fact that we are the importance of bringing this the AI plumbing to the AI problem is actually more of the problem than anything else, right? And that's why this work is so important. And to me, there's an important principle that comes from interaction design, which is this. When we build infrastructures, they are not just following the demand, the requirements of the research communities. What the infrastructure makes easy is what happens. There's a theory in interaction design called affordances, which notes that, we'll do a hand up. We can't do hand up because we're not in it, but umpteen thousand trillion times, I have totally pushed the pull door and pulled the push door when trying to go into a building. But if you do it like this, so there isn't a freaking handle on the push door, right, then you'll only push the push door and pull the pull door because the handle tells you what to do. this is important because when we build our infrastructures, it influences behavior. So we can actually create quite a powerful steer and get the kind of research and scholarship we want by building the infrastructures right. And when I come to talk about trusted research environments and data safe havens, I'll come back to this because I think, so never let it be said for those of us who are working in this space that all we're doing is giving people what they want. Because this slide is key to the philosophy. So when we are thinking about what to do when we're designing these infrastructures, again, it's a combination of utility, the service to applied research, and curiosity, the fact that understanding how to do digital infrastructure well is itself an interesting research topic, and those are and balancing those two criteria in the design of these things is what I've been talking about so far. But there's a third point that I want to include in sort of the selection criteria that I think about, which is how do we use digital infrastructures to bring communities together. For me, one of the things I'm excited about within the work we're going to be doing in building a national digital research infrastructure is moving away from what I unfairly characterize as local supercomputers for local people, referencing that classic comedy show. Because instead of saying, right, okay, this is the supercomputer for this research domain, and this is the supercomputer for this research domain, where I want to move to, and this will take time, we'll have to bring the communities along with us and do this by consent. We need to have a diverse and distributed and interoperable infrastructure such that the workloads go to the facility which is most appropriate. Thank you, Jethro. What was I going to say? Yes. So the workloads flow to the computer facility that is most appropriate for the research work at hand. So one facility might be most appropriate for a workload which needs intensive read from disk. Another might be focused on a workload which needs GPU supercomputing. Another might be focused on high throughput computing, which needs fast network access to download remote data sets. All these different kinds of things. This is why we mustn't have one big monolithic supercomputer for everyone, but nor should we say, okay, this one is only for this domain and this one's only for this domain. We can bring our communities together so that the facilities are common to the whole of the scholarly community, and the workloads find their way to the piece of radio. And what that means is that in order to deliver that, it's also creating the digital infrastructures are bringing researchers from those different domains together, some more mature and some less in the use of different aspects of digital research, together around the infrastructures. So that piece is really important to me as well. Okay, I'm just going to buzz forward through my slides so I can remind myself of the slides to come. Good. So the next point I want to make is one of the reasons why I care about the software piece in this so much. When we are making critical decisions using digital research methods, they will be challenged, and they will be subject to people challenging them, quite rightly. And so science can become a political football, which is what this slide is supposed to illustrate. So someone's hopefully kicking science into the goal. And if science is a political football, then the results of it have to be auditable. They have to be go beyond, I would argue, traditional standards of scientific reproducibility and bring us to the point where where we need to be able to demonstrate the audit trail from code through deployment, dependencies, all the things which might affect the results to outcomes. That's a challenge, and it's a challenge that IT professionals in research we can make an enormous contribution to. So that auditability and correctness piece, I think, is really vital. One of the reasons, going back to the startup that I mentioned, one of the reasons the startup that I was working for ran into difficulty was that there was a drop in what they call the clean tech market, the market of people working in computing and data in the environment of climate change, because there was a fake scandal around a bug in one of the big climate modeling codes at that time. And that really was, one of the things that taught me a lesson of how important correctness and auditability in digital research is, and one of the things that is motivating a lot of the work I'm doing in the context of CV19. So the next area I want to come on to, sorry Alex, is that universally held? I can maybe sit close to the screen if it's causing any problems. I'm just pausing to address any sound issues. Okay, so it sounds like it's internet weather somewhere in the world. The next area I want to talk about, and another area that I think is going to be really important to focus on in the work around this, is doing digital research with sensitive or personally identifiable data. A lot of our computing infrastructure has been built with, imagine, nobody really minds if the positions of all the stars leaks, if we're doing astronomy supercomputing. But if patient data leaks, it's going to undermine the social consent for digital scholarship. So for me, the work we're doing around trusted research environments or data safe havens, so that we have almost all of the national digital research infrastructure is fit for purpose for handling sensitive data, is going to be critical. And we're seeing this in the context of the work that's being done around TRE for analysing CV19 data at the moment. But that doesn't just mean making secure systems, because if we make unusable secure systems, our research communities will work around this. And this is a clear message that I want to share with those of us that are making that are building secure research infrastructures. We are as morally responsible for a breach if, because we make the system unusable, our user community works around us and decides to do the work on their own laptop instead of using the data safe haven, as we are if there's a breach from the system we control. This is difficult news for some. You say, oh, no, that's not true. The user wasn't compliant with university policy. We told them they weren't allowed to work with sensitive data on their own laptops. They should that's their fault. The message I'm trying to get across is I don't agree with that. We must make these systems usable enough because of affordances, because of the design theory around user behavior is something we can incentivize. So we must make these systems usable so that the workaround breach is not the serious issue. And I want to highlight some work I did in my. So I haven't got too much to. A lot of the examples I've been using in this talk have been work from my old job in the Turing rather than from a new job, because I haven't done much yet, because I've only been doing it a few months since the beginning of the year. Also, COVID came at an annoying time when you just started a job like this. Thanks, Fiona. But I want to emphasize the importance of getting good classification, over-classification and under-classification. And friends in Cheltenham and elsewhere have understood this for a while. Getting classification right is really important. So I look forward to doing a lot of work helping to, in budgets, I hope will be sorted for this, investing in trusted research environments so that we can get classification right, enable them to be fit for purpose for curiosity-driven, playful research with at-scale data, big advanced computing inside the data safe haven, and top world-class security standards. And I think that should be an and rather than or. And seeing Vin's point, yeah, the sharing of data is a really interesting one around data trusts and so on, which is going to be another really interesting area. All right, so the next area I want to talk about is the importance to me of research technology professionals. So when I told my story at the beginning, I talked about how important when I talked about the research software engineers and the growth of that particular example of moving roles which traditionally have been done in a way by sort of postdocs, like the computer person in the lab who's on an RA contract but is in a very precarious state, and moving that into research IT organizations through the research software engineering groups, I think has been enormously important to build institutional memory, to create stability, and there are many other kinds of research technology professionals, many of the people in this conference, for whom we need to do, we need to invest so that these roles have a parity of esteem with more traditional roles and more traditional research career paths, and have and are seen, I believe, as a really critical part of the infrastructure. So a key part of the mission for me is to have the arguments to make sure that we don't only get capital when it comes to investing in research infrastructures. I cannot promise success on this. This is a difficult challenge. But the importance of sorry, David. I thought it was a funny picture, but I'm sorry to have triggered you. The importance of finding the way to build the place within the scholar community for research technology professionals. I remember one supercomputer from a few years ago, which was one of the first GPU supercomputers in the world, in the UK anyway. And I knew the user. It was a chap called Dave. And that was because there wasn't the support and nobody knew how to do the programming at the time. And if we invest in the hardware without investing in the support, money will be wasted. And that's a consistent message that I want to be giving to UKRI leadership and government throughout this. And that's why our research technology professionals are critical. And that's not just research and software engineers. It's only one small subcomponent of the whole space of research technology professionals. And we've got our data scientists, but we've also got our systems engineers and the DevOps professionals in this, and critically, I think, the data stewards. Because another one of the areas that I think is really important is building on one of the things we're seeing in the CV crisis, in the coronavirus crisis, right, is that when everybody's super busy, the only way we can organize teams of this scale is through the open methods that have been developed, the technology, the pull request, and open data facilities and so on. And to work now, obviously, open is a bit strong for some of this because we can't put patient identifiable data out on the internet for everyone to download. But the intermediate standard of findable, accessible, interoperable, and reusable fair data, I think, is really critical. But it's labor intensive, right? Going from, and making data accessible and reusable means, taking it out of the PDF and into the database. It means putting it behind a good API. It means putting a good discoverability layer on it. And all of those pieces, I think, are absolutely vital to the kind of digital scholarship we want to enable. And there's some really interesting work going on bringing data onto the balance sheet and seeing it as an asset, seeing it as a capital asset. And yeah, all the metadata is absolutely vital for this stuff of various kinds, including, yeah, I strongly agree with Alex as well. So you know, so Highways England are doing some really interesting work on noting that not only is data itself the data on the balance sheet, but the level of accessibility of that data, is it sitting in a bunch of disorganized PDFs, or is it well curated? Is itself part of the value they're putting in terms of data on the balance sheet, which I think is really going to be really important. And the set of professionals who can deliver that high quality reusable data, rather than just, oh yeah, the Research Council said we had to deposit our data at the end of the research project, didn't we? Sticks giant file somewhere, completely disorganized. I've now completed my data deposit requirements. Right, we need to invest in the data stewards that will make this really usable. So that's really important to me. So all of this has been various bits of ranting towards the idea of a joined-up national digital research infrastructure. I want to emphasize again, this doesn't mean one big Stalinist project where we do everything from top down. It's got to be diverse and distributed. It's got to have components being built in. I like to talk about what I sometimes call the slime mold model of interoperability, where we have lots of individual bits all done completely separately, and then they gradually coalesce into a, as we turn up the interaction parameter, into a collective superorganism. That won't make sense to people who don't know that bit of biology, so apologies. But anyway, the idea of diverse and distributed but interoperable and coherent is really important as part of that. This is the slide that says data and computers and code and people again. There we are, which I usually use to conclude on. Thanks.
Thank you for your fascinating talk, James. It's certainly generated a lot of comments in the chat box. One of the ones that did come up was from Vin Everett from Cambridge. Only 10% of current science is repeatable, and as such is science. The other 90% is noodling around and unpublished negative results. Simulations have to be backed up.
Yep, that's all bang on. I really, and the whole reproducibility crisis piece is something that I care about a great deal. And one of the things that I think is important about what we do as research technology professionals is, again, using affordances to make it more likely than not that people use methods which will encourage reproducibility. So, for example, every single person doing a computational science PhD, by the time they've finished their PhD, has built their own model run manager for organizing the results of computational experiments. Like, everyone's freaking done it. Like, that's done, right? Let's have some common and shared infrastructures around organizing computational experiments so that we don't doing the, I know. I reckon probably sometime in the last 2 years I might have run the simulation with some parameters that somewhere. So, you know, we can do better than that, right? And that's just one example of where good underpinning tools, and finally, I mean, how we do it, look, we've got to work this out together. How we get people so we are actually standing on the shoulders of giants instead of completely ignoring the previous giants and starting again within the computational sciences. I don't know, but I think my hypothesis is we can do more with the infrastructures and more with the tooling and more within the support communities to address that than I ever could by doing good practice as an individual working computational scientist. And that's why
another question we've had in from Owen Kenny is any concerns on using storage in private versus commercial data centers?
Good question. So what do we do about the role of the commercial cloud vendors in the provision of high throughput computing, and I think I specifically focused on high throughput computing rather than high performance computing on this. There are arguments over whether or not the commercial cloud vendors are ready for high performance computing, and the boundary of what we call high performance versus high throughput and how many nodes it is before it is designed. So, but high throughput computing, do we want to do what some countries in the world have done and build a national compute cloud on, in our own data centers using OpenStack or any of the other tools that are around for making your own clouds? Or do we want to have an agreement as a research community with one or more of the big commercial cloud vendors to do that? That's a really complex and subtle question with lots of economic issues, total cost of ownership issues, but also some interesting issues around the nature of particular data sets we're working with, and in some cases some national security issues. So really fascinating one. I'm not going to make a snap judgment on this. It's one that we are, the economic case will be really important too. The UK research cloud for research computing working group led by Phil Kershaw has been doing some really good work around this space, and I hope that work will continue. Yeah, thanks, James. Yeah, good. My suspicion, my prior would be we'll need a mixture, honestly.
Maybe one question from me. What do you think has been the biggest challenge to the research community in the current pandemic?
Well, honestly, I think it's not the work we're doing on the research side. It's the work that colleagues are doing around just making sure that we don't lose capacity during the, it's all the people who, within UKRI, there's the group I'm on, which is the CV19 Research and Development Committee, but there's another group that's working on UKRI's response to, the issues of how do we make sure the universities are not damaged in a way which causes capacity not to return after the crisis. And it's that challenge, which is the much more serious one. I've got the easy side of the challenge, working as part of the group that are looking at how we can, do more to use, the research that will help us get out of this, than those with the much more worrying policy questions on the other challenge. If I can therefore restrict my answer only to the sub-part of the question that I have some connection to, rather than the stuff that's not within my scope, I am conscious of the following risks. We do not want to do what I call COVID washing, which is to say doing whatever it was you were going to do anyway and spraying a thin layer of applicable to the pandemic over the research you wanted to do anyway. Which is why I think it is important that while we not create bureaucratic barriers to get in the way of urgent research, we do actually still have a jolly appropriate level of due diligence about things like urgent access to national computing facilities around for CV19 related work. Because most COVID washing isn't people being actually malicious. Our brains are always biased in favour of the importance of our own work. That's why some people will do it inadvertently. So I'm very aware of that. I'm also aware of the fact that we in the computational sciences are lucky. So long as the computers stay up and we don't need to rush into the data center and actually fiddle with some cables, which I know all of our facilities are running at risk at the moment, we can carry on work, right? We can carry on work because in a way that experimental colleagues are not able to. So I am aware that the digital, the Research 4.0 brings resilience to the research landscape because we can do the digital, which be in silico rather than in vitro or in vivo work. It has business continuity properties that are great at the moment. But I'm really worried about seeming like a vulture right? And making the argument, oh, did you know that the only thing we can carry on now is digital research? So therefore, because that's I think more than just distasteful. So I think it's important to recognise the important power that digital research methods are bringing, and they are making a huge difference right across the response, while at the same time really recognising that we are not the heroes.
One last
here,
question.
Right? The heroes are the key workers on the front line.
Any thoughts on how researchers could better share work-in-progress research? With COVID-19, there can be little time to wait for work to be published in the traditional way.
Absolutely. So I'm really glad that the UKRI has endorsed the proposed statement of values on this from the Wellcome Trust. Everything that's coming through the UKRI CV19 urgent R&D call is subject to a very, very, very strong policy on fair and open data sharing, and I'm pleased to say on software sharing and algorithm sharing as well. So all the foreground IP that's emerging in the software side of things will be shared openly, and I think that that's tremendously important in this piece. I would also argue that I am aware of a number of projects of different flavours that are happening within this space, and the ones that are attempting to maintain a coordinated command and control structure are finding it very difficult to coordinate the scale of the response, and the usual thing around. I was inspired by the response to the Royal Society's Rapid Assistance for Modelling the Pandemic call, but the risk when you say, hello everyone, who would like to help with the coronavirus? Everybody puts their hand up. Of course everybody puts their hand up. So how do you organise that? We have technologies that allow us to organise humanity at internet scale. The pull request is one of the key ones. So I think one of the things we're learning is if we need to cooperate at the scale of the planet, it's only the technologies that we've developed for web scale sharing, open data sets, pull requests, FAIR data. Neil Chiang made a great point the other day that during the crisis, nobody has time to explain how things work. So documentation's importance has gone up because you can't get the time with the person to, can you explain to me how this code works, please? So all of those things, I mean, again, the things we've been talking about in terms of good practice remain good practice, but boy heaven, are we seeing just why we stand by those good practices. And I'm completely fine now that we are acquiring technical debt during the crisis. Now, I know loads of awesome stuff that's happening where people are not following all the good practices that we're at, and that's fine, right? The best must never be the enemy of the good. And I'm also strongly opposed to the flavour of open science sneering, where open science zealots scare people away because you're saying you're not doing everything perfect.
Thanks, James. I'm going to bring this session to an end. We've just run over slightly. So can I say thank you very much for a fascinating talk. You've generated loads and loads of stuff in the chat pane. If you want to look at it later, then we'll be able to supply you with the transcripts from that. So many, many thanks. Glad you could participate in Networkshop Online, and hopefully you can stay on till the end if you want. But just to say, we're now going to break for 15 minutes before the next session, which is on cloud. So see you all in 15 minutes.
Great.